Alright guys, welcome to this page of the notes. Now again, what we're doing here is we are working on solving systems of equations algebraically. That means using either the substitution or the elimination method. So let's jump right into this one. I have two equations and what sort of jumps out at me right away is that substitution is not going to be a good choice. So we're going to go elimination. The second thing that jumps out at me is that both variables, both the w and the z's, have coefficients that are opposite in sign. Fantastic. What I now need is the same coefficient, which I don't have. It's a -6 and a +3. The z is a -8 and a +6. That means I'm going to need to multiply these equations by something. In order to get those coefficients to be the same, multiplication is required. Now remember, my little trick for you, that it's small, but it is a shortcut. Choose the variable whose coefficients have the smallest LCM. Well, 6 and 3, the LCM is 6, right? 6 is a multiple of 3. So that's a really low LCM. But let's try the other one. I have an 8 and a 6, and that LCM is going to be way bigger, way bigger. So that means I'm going with the W's. So here we go. Looks like what I'm going to want to do is this -6W minus 8z is equal to a -44. I'm not going to multiply that by anybody, right? Because my LCM is 6 and I already have a 6. But what I do need to do is the second equation, which is going to be a 3w plus 6z equal to 36. That one's going to need to be multiplied by a 2, right? Because the 2 is going to get me a 6 here, and then those w's will drop out. So let's go ahead and make that happen. I wind up with -6w minus 8z is equal to a -44. And then I'm going to have 6w plus 12z is equal to 36 times 2, what, 72? Yeah, 72. Alright, I add the equations together, the w's drop out. We've successfully executed the elimination method. So what have I got left? Well, -8z plus 12z should leave me with 4z. And a -42 plus 72 should leave me with a +28. Which means that z is going to be equal to 7. Alright, so that definitely can happen. We've not seen this before, but now we have. It is totally possible that in order to successfully do the elimination method, you actually only need to multiply one of the equations by a coefficient, which is great. Saves you a little bit of time, hopefully. So now I just need to pick which one of these I'm going to plug. Again, I like positive numbers better, so I'm definitely going to go with that one to solve for z. 3w I know that my z is a 7, so 3w plus 6 times 7. Of course, 6 times 7 is 42. It'd be a +42, so I have to subtract it to the other side. (36 minus 42), what, I get a -6, and divide both sides by 3. W would be equal to a -2. Now, the ordered pair, the W comes first, the Z comes second, so -2, 7 would be my solution. I got another problem here. Let me scroll this guy on up, and let's give this one a shot. Once again, we're looking for the fastest way to solve this system of equations, so let's take a quick look at it. Is substitution going to be the right method for us here? And substitution is not. Do I have a Do I have a variable that already has either the same coefficient or opposite in sign? Well, I got a +8 and a +5, so that's no bueno. I got a -3 and a oh, that's not bad. They're opposite in sign. Not the same coefficient, but they're already opposite in sign. So that'll work. Yeah, here we go. I'm going to multiply. Actually, you know what? Instead of rewriting them, let me do this. I'm going to multiply this first guy by 2. multiply the second guy by 3. And what that's going to do is this is going to wind up giving me a positive 6b and a negative 6b, and those b's are going to drop out. So here we go. That's going to give me 16a. No, sorry. Let's go with black. 16a minus 6b minus 22. That's going to give me 15a plus 6b equal to a minus 9. Add them up. B's drop out. Great. 16 plus 15. What do I get? Should be, what, 31? Yeah, 31. And a minus 22 minus 9 should be a minus 31. How about that? So A is equal to a negative 1. Pick one of those original equations to plug my answer back into. I like 5, 2, and negative 3 better. So 5 times a negative 1 plus 2b is equal to a minus 3, which means 2b is equal to a minus 3. This would be a negative 5. I'd add it to the other side. Oh, look at that. 2b is equal to 2. B is equal to 1, and I have negative 1 comma 1, right? Because it'd be a comma b, since the a comes first and the b comes second. There's your solution. The system is both consistent and independent. And actually, I think what I've got for you is another problem on the next page. So let's go ahead and do that one as well, since I believe this is, yes, it is. So this is the last one like this. The rest of them are word problems. So let's go ahead and we'll do this one as well. We're going to want to take a look and see if substitution is going to work. And substitution will not work. So then let's go ahead and check out elimination. Who are we going to eliminate? Both of them already have coefficients that are opposite in sign. Fantastic. So now it comes down to LCMs. 5 times 2 would be 10. 15 times 6 is way bigger. So we're going to get rid of the A's. Let's multiply this first guy by 2. Multiply this guy by 5. And those A's are going to drop out. That's going to give me 10A plus 30B is equal to a minus 48 minus 10A. Let's see, it's going to be a minus 30B is equal. 5 times 28, sorry, real quick, calculator gives me 140, positive 140. Add them up. Oh, look at that. Look at that. Look at what happens. I have a positive 10A plus a negative 10A. Yeah, those drop out. That's what I was expecting. I did all of this to eliminate the A's. But then I wind up with a positive 30B and a minus 30B. No, you didn't make a mistake. That actually happened. Those drop out as well, and you're left with a big old goose egg over here. 0. Negative 48 plus a 140, I get 92, and the question is, does 0 equal 92? No, 0 does not equal 92. What you've got yourself here is a false statement, and it took us till all the way here at the end of the notes to finally get to one of these, but we got here. You wind up with a false statement, and hopefully you remember back, I've said it a few times now, that when you get a false statement like this, what it means is you have lines. These guys, if you were to graph those linear functions, they would be parallel lines. They have the same slope, different y-intercepts. These lines do not intersect, and you have a system that is inconsistent. Of course, inconsistent means there is no solution. Those linear functions would never cross each other. There is no point of intersection. Okay, that takes care of all the problems where we do the substitution elimination. We're still going to work on solving systems of equations, but what we're going to take a look at in the next video is some word problems. So head on over to the next page of the notes, or actually just scroll down on this page of the notes and I'll meet you there.